All right. Today we're going to look at section 8.3, which is special right triangles. Our two main learning targets, we're going to find the missing sides of 45, 45, 90 triangles and 30, 60, 90 triangles. So one thing that we do know, if we are looking at a triangle that is a right triangle, and this angle is 45, we know that this one has to be 45 as well because of the triangle sum theorem. They all have to add up to 180, so those two have to be the same. We also know that we can pay attention that these two legs, because the angles are congruent, those two sides have to be congruent. So that's our first type of special case triangle that we're going to look at. The second one is a 30, 60, 90. All right, so if we know that that's 90 and we know that that's 30, triangle sum theorem again, this has to be 60 degrees. All right, so if you're given one of those angles, you can find out the other. All right, we do have to add a little bit of working with square roots. Again, we haven't done this before. This is going to be called rationalizing the denominator. So part of what we're going to do today, you're going to have to divide something by the square root of something. We don't want a denominator to, we don't want to have that square root in the denominator. We want to get rid of it. So what we can do, multiply both the top and bottom by whatever is in that square root. So square root of 5 over the square root of 5. We can do that because that's essentially just multiplying it by 1. What will happen? We'll have 2 times the square root of 5. And the square root of 5 times the square root of 5, we can treat these things like parentheses, multiply the numbers together. That's going to be the square root of 25. 5 times 5 is 25. Now, we can take the square root of 25. That's going to be 5. So our final answer, 2 square roots of 5 over 5. All right, next one. It's got a square root of 6 on the bottom. So the same idea. Multiply the top by the square root of 6, the bottom by the square root of 6. So we'll have 4 times the square root of 6 over 6. Square root of 6 times the square root of 6 is the square root of 36, which is 6. And the last one, multiply both the top and the bottom by the square root of 7. We want to get rid of that square root on the bottom. So 14 times the square root of 7 over 7. So you should start to see that pattern there. Now we can reduce this a little bit. 14 divided by 7 is 2. So this would just be 2 times the square root of 7. All right. Now let's look at our 45, 45, 90 triangles. So one thing that we know, because they're the same angles, the sides are the same. So if we label this leg X, the other leg has to be X as well. What will happen is that the hypotenuse will then automatically be X times the square root of 2. We can look at see why that works with this 45, 45, 90 triangle that is a leg of 1. All right, 1 squared plus 1 squared equals c squared. So 1 squared plus 1 squared is 2. Take the square root of both sides. That makes this side the square root of 2. So now however how many times bigger than 1 that is, we can just use an x instead of 1. It'll be x times the square root of 2 for the hypotenuse. All right, so for our example, we're going to find the missing sides. It's 45 degrees right here. We know this is 45, so if that's side 7, that side is 7. Now, super simple. This side is x. We're going to label that. The sides of a 45, 45, 90 are x. This is going to be x times the square root of 2. So now instead of x, I can write 7. So this is 7 square roots of 2. All right. In B, we're going to label this x. The sides are x. The hypotenuse, always identify your hypotenuse. That is going to be equal to x times the square root of 2. This side is also x. What we have now is an equation. 3 is equal to x times the square root of 2. We want to get x by itself, so divide both sides by the square root of 2. All right, that'll cancel out here, and we'll get 3 over the square root of 2 is equal to x. This time we want to put back in the same thing we did before, get rid of the square root on the bottom, multiply the top by the square root of 2, and the bottom by the square root of 2. So we'll have 3 times the square root of 2, and the square root of 2 times the square root of 2 is going to be square root of 4, which is 2. So my final answer for this side is 3 square roots of 2 over 2. All right. Now, get in the habit of labeling your sides. Call that one x. This one's x. So this is x times the square root of 2. Since we know x is 10 times the square root of 2, we can just substitute that in. 10 square roots of 2 times the square root of 2. We can simplify this. The square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2, so it's 10 times 2, which gives us 20. So this side is 20. And one more nice, easy example. Label this side x. This is x. This is x times the square root of 2. The hypotenuse for 45, 45, 90 is always x times the square root of 2. All right, so now we have whatever one has your equation, x is 5, x equals 5. So this side is just 5 times the square root of 2. All right, now a 30, 60, 90 triangle has other similar ideas of patterns and characteristics that we can look at. The short leg is opposite the 30-degree angle. We remember earlier, the smaller the angle, the smaller the side. We're always going to label the short side x. Label your hypotenuse 2x. The hypotenuse is always twice as big as the short leg. It's one of the tricks of the way these triangles work. The long leg, opposite the 60, it's the square root of 3 times the length of the short leg. So we are going to label this one x times the square root of 3. All right. Now let's look at a couple examples. Across from the 30, we're going to label this x. So that means the hypotenuse is 2x. And this side is x times the square root of 3. This one gives us an equation. So 16 equals 2x. Divide both sides by 2. 8 is x. So now we know that 8 is x, just plug it in for x wherever you see it. So this side is 8. This side is 8 times the square root of 3. Okay. Label your triangles. So, since this is 60, this has to be 30, so that makes this x. This side is 2x. This side is x times the square root of 3. Whatever gives you that equation is what we're going to start with. 11 equals x times the square root of 3. Divide both sides by the square root of 3. So we have 11 over the square root of 3 is x. We want to get rid of that square root of 3. Multiply the top and the bottom by the square root of 3. So it'll be 11 times the square root of 3 over 3. All right, so that's our x. That's what this side is. And this is 2x, so this is 2 times 11 square roots of 3 over 3. So that's 22 square roots of 3 over 3. If you can reduce the fraction, do it. In this case, we can't. But this is my final answer for this side right here. All right, 2 more. Label your triangles. This is the 30 degrees. So this side is x. This is 2x. And this is x times the square root of 3. All right, so the square root of 10 is 2x. Divide both sides by 2. And x equals the square root of 10 over 2. Notice you're not going to take 10 and divide by 2. The 2 is not part of the square root. So now we can plug this into here. We know x, we plug it into our third side. So it's the square root of 10 divided by 2 times the square root of 3. Okay, we can take out, or we can simplify this by multiplying inside the square roots. 3 times 10 is 30. So it's the square root of 30 over 2. All right, so this side right here, square root of 30 over 2. Again, you can go through and look and see if this has any perfect square factors. I don't think it does. Nope. So we'll leave it as that. All right. And our last one. Label your sides. This side is x. The hypotenuse is 2x. The opposite, the 60, is x times the square root of 3. All right, so since x equals 5 times the square root of 3, 2 times 5 times the square root of 3 makes this side 10 square roots of 3. Plug the x in here. 5 square roots of 3 times the square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is 3. So that's 5 times 3, which is 15. So that can give us these other sides if we only know one of the sides. So you cannot use the Pythagorean theorem here because we only know one of the sides. We won't be able to just do the a squared plus b squared equals c squared. But if you use this process, you'll be able to find that way.